Thanks, Lev. I think it's a great pleasure to have all of you come to Yahoo Tel Aviv. What we did with the NFL is what I'm going to talk about today. A lot of it was because of a lot of the work that is done in Tel Aviv today in Lev's team. My group is responsible for the video platform and some of the video products that we build at Yahoo. And we started talking about NFL and doing this event around June of last year. And we had about 4 to 5 months to build and to develop some of the technologies and some of the innovations that we had to do to deliver the event. And I'll talk a little bit about that. Before I get into the talk, I wanted to first get a sense of the audience. So I wanted to understand how many of you are either in the video or networking space. If you can raise your hands, it'll be great. Oh, almost everybody, so great. I don't have to explain some of the terms that I use here. And the other key thing I do whenever I go to give this talk is to understand, how many of you stream video on the internet today? Hopefully it's 100%. Well, clearly it is not. It's only about 40%. That's interesting. As we all know, there is a lot of, at least in the US, we see that there is a significant shift in the behavior of subscribers of cable television who consume a lot of TV and programming on TV. We see that TV subscriptions are going down, and cable and satellite subscriptions are going down, and a lot more consumption is happening on video. In fact, there is roughly 3x of video consumptions among millennials. Millennials are basically the 34 and under age group that are identified in the US. And clearly a lot of the industry, basically content providers, are noticing that. And content providers are deciding that, hey, a lot of the consumption is moving to online. A lot of the people are watching more and more video online. Let's take our content online. And you'll see things like HBO, ESPN, and a lot of the biggest content providers, which are live sporting events, are the ones that are also noticing this. And that's what motivated a lot of the work that we did with the NFL. So let me get into the talk. What I'm going to do is first talk about, why Yahoo, why NFL, and what did we achieve, and then I'll talk about how we achieved it. So for those of you who don't know about the NFL, NFL is the #1 sport, most watched sport in the US. For example, this is the number from the Super Bowl in 2015, not this year. In fact, this year is also pretty close. There were 120 million viewers of the Super Bowl in February of 2015. These are TV viewers. And this year also on TV, roughly in the same order, roughly 110 to 120 million viewers on TV for NFL. Another interesting stat that very few people know about is that in fall of every year, there is a fall season that starts in the US, where you have primetime shows that premiere and they show. It's very interesting that 45 out of the 50 fall primetime viewership, the highest viewerships were of NFL games in the US. Just imagine that. You have about 20 to 25 million viewers come and watch NFL games on Sundays, on Mondays, on Thursdays, on TV. So viewership by far of NFL is much bigger than most of the sports in the US, be it MLB, be it NHL, or whatever. So clearly the NFL was seeing a trend is seeing a trend where a lot of viewership is moving towards online. So they came to Yahoo to talk about how do we do the streaming event in October. And why Yahoo? Because Yahoo has a very big audience. We have about 1 billion users who come to Yahoo on a monthly basis. Not only that, it has some of the biggest, I'm going a bit early, but it has some of the biggest sporting franchises. For example, Yahoo Sports is one of the biggest franchises. We have daily fantasy, we have fantasy sports. They are NHL, we have NFL, NHL, MLB fantasy. A lot of people come and play fantasy sports on Yahoo. That's a big franchise. Not only this, we have a very big global sales organization that can go and sell ads and monetize content. Yahoo has audiences all around the world, and we are able to monetize that audience. In addition to that, some of the key innovations are also built at Yahoo. For many of you who use big data, you'll know that Hadoop and a lot of the infrastructure that we have around big data was actually built at Yahoo and open sourced that most of the industry uses today. Not only that, we also, for those of you who don't know, we have some of the best cloud innovations that we have, be it nosql, storage systems, cloud infrastructure. In addition to that, some of our video streaming infrastructure is also pretty world-class. And that's one of the reasons why they would pick somebody like Yahoo to work with. And finally, Yahoo has some of the best partnerships. We have partnerships with a lot of media and content providers. For example, the NFL, we have partnerships with PGA, we have partnership with NBC Sports. We have a lot of different partnerships that we can then leverage to deliver content to a lot of our audiences. So when the NFL came to Yahoo to do this event, they said, hey, we want to do this game. This game is going to be held in London on October 25th. That was about 5 months away. We started working towards this. All our teams in video and Yahoo started working together. And we decided that we wanted to measure ourselves and figure out what does success look like. So what does success look like for this event? When we worked with the NFL, they said, these would be the parameters, right? What are the first parameter is we want to make sure that we have a global reach. That is, we are able to reach audiences all around the world. One of the, as I showed, the NFL is a US-centric audience. We have a lot of viewership in the US, but they wanted to reach a global audience. There are fans of the NFL all around the world, want to reach the fans all around the world. Second is, we just don't want to make it just like as it is in TV, we want to make it more than TV experience. So we want to have a differentiated experience that the viewers can get. And finally, we wanted to make the quality exceptional. We want to make sure that the folks who see games, sports on TV get extremely high quality so that they potentially can get TV-like experience or TV-like quality that they watch sports on. So that's kind of the key goals that we set up for ourselves. And how did we do? So the great thing about this event was that we had a fantastic user experience. Some of the tweets that we got for what it was called the Watch with the World was great. We were #3 trending in Twitter. Not only that, a lot of our industry partners, in fact, a lot of the people in the industry noticed us and said that we gave an exceptional experience. For example, you see people saying it was a quick start, no rebuffering. It was an unmitigated success. We streamed the event without a hitch, and so on and so forth. A lot of kudos from the audience as well as from the industry. In addition to that, the NFL was also super thrilled. They said that we had opened a new way to reach fans, a new platform to reach fans. In fact, we were also considered to be exceptional or a tremendous success and did a phenomenal job in the game. And overall, the feedback was positive all around. I've given talks in streaming media in the SVA Alliance, a bunch of places, and overall the industry feedback has been phenomenal. If you look at it from a scale perspective, it was one of the largest sports live streaming event in US history. We had 33 million streams. We had about 15 million unique viewers. We reached 185 countries, and about 30+% of our users were international users. So it was pretty big. In addition to that, we managed to give a pretty differentiated experience to our viewers. What is the experience was put up on pretty much all Yahoo properties. We could deliver to our Tumblr audiences all around the world. We were able to reach audiences on yahoo.com. It was there on sports, so people who had the sports, who visit sports on Sunday mornings to participate in the NFL, the NFL fantasy, they could watch it. They could watch it on their apps, on the phone, and so on and so forth. In addition to that, we also reached a lot of NFL audiences on NFL.com. We had our player put up there. In addition to that, we had a unique experience from a user perspective where, in addition to 2 languages, we had English and Spanish. We also had a third commentary channel, which we had fantasy football live commentators who were sitting in a studio in Yahoo and providing a commentary on top and an audio channel on top that users could use, users could hear. And the feedback that we received for this audio was fantastic. People loved it because it was very funny. People came, they could actually hear people like them giving commentary on top of the audio that was provided. And finally, we were able to reach many devices. We could reach connected devices like Apple TV, Roku's. We were able to actually reach connected TVs as well. So on Samsung, Vizio, so on and so forth, they could watch us. We were able to reach on, obviously, desktop and laptops, on mobile phones and tablets. So this was a pretty broad reach, unlike what they do on traditional TV. And then from a quality perspective, which was one of our key metrics, we were able to deliver this experience on 720p at 60 FPS. So one of the things that we were very particular about was that people who watch sports, fast action sports on TV were able to get the same experience on their laptops, desktops, or mobiles. So 60 frames per second was a key innovation that we wanted to make sure people get it at. And that was something that we did. Our bit rates were pretty high. We reached up to 6.7 megabits per second. We had some 9 different bit rates in our profile. And the best part of it was our rebuffering ratios were very low. In fact, our overall rebuffering ratio was less than 1% across the world. And in the US particularly, our rebuffering ratios are very low. It was about 0.6% for a live game, which was unheard of because from all our talks in the industry with a bunch of people who measure this in the industry, the rebuffering ratios of 1.5 to 2% is normal. And we had a rebuffering ratio of 0.6%. How many of, I hope you guys know what a rebuffering is so that I don't have to explain. Okay, cool. So how did we do this? And a lot of the innovation that we did was around the technology that were enabling us to provide this experience. Okay, so we did this by, and I'll talk about what we did in the player, what we did in our delivery or the CDN, and what we did through our operational excellence. A lot of the work that was done in Israel as well, so you'll hear about that. So what did we do in the player? So the first thing we did is we built techniques by which our adaptation of bit rates was phenomenal. So as you all know, what a bitrate adaptation is basically adaptation to the bandwidth available to the end user. So you have pipes all around the internet, all the way from where the stream is being produced to the point where it reaches the user's device. Now the pipe keeps changing in size and width, and therefore you have to make sure that you are able to deliver it on the thinnest or the smallest pipe that is there to the user. And that pipe changes. This game is for 4 hours. The pipe is not constant, right? The pipe keeps changing. So you have to adapt to it. And that's what adaptive bitrate does. So what happens without adaptation is that you have very high rebuffering. So the first thing we wanted to make sure is that our rebuffering is low. The second thing is without adaptation, or even with adaptation, we want to make sure that the bitrate that reaches the user is the maximum or the best bitrate. So the average bitrate has to be high. And the third thing we want to make sure is that the startup time is quick. So we built different algorithms for doing that. And in addition to doing algorithms, we did thousands and thousands of tests to make sure that our algorithms actually work. And this is one such test. What you see here is a bandwidth of a user's network where you first start off, you have a bandwidth of about 10 megabits per second, and then the bandwidth reduces to almost 0. Right? And then it slowly climbs up. And this is typical, right? In your home network, you will have, or even in a Wi-Fi network, or in a cellular network, LTE network, you may have collisions, you may have interference, you may have range issues. What happens is the bitrate keeps varying. The bandwidth keeps varying. So what happens in traditional adaptive bitrate algorithms is usually the device or the player slowly keeps increasing your bitrate till it reaches some point, at which point it will keep it as long as the bandwidth is available. In this case, what happens is the bitrate slowly starts increasing. It reaches a point where it reaches roughly like 3 megabits per second, at which point suddenly the bandwidth has dropped. And in this case, what happens is for some period of time, roughly about 10 seconds, the user sees rebuffering because the bandwidth has come to 0. The bitrate has reached 0, right? So this is a problem. And what you see is in our algorithms that we've developed, we reach much higher bitrate in this case, where we reach all the way up to about 8 or 7 megabits per second. And then as soon as the bandwidth drops, our algorithm is able to still maintain the capability of delivering video to the user. So we see 0 rebuffering in our case. And this is just one such example, right? These are thousands of such tests that we were able to do. We, in fact, built a simulator where we could simulate different types of network environments and run our algorithm to that to make sure that our player recovers gracefully under various conditions. And we were consistently able to produce cases where our algorithms outperformed the industry standard algorithms. And that's one of the reasons you see our rebuffering ratio to be almost 0. So in this case, as you see, our average bit rate is much higher, our rebuffering ratio is much lower, and our startup time is much faster. Just one such example. Yeah, go ahead.
The question that I have in my head is about syncing between devices. Let's say that I'm sitting here watching the Super Bowl, and while over there my friend, my colleague, he sees the Super Bowl in his device. I don't want to hear him shouting a goal.
Yes. Yeah. So that's a very interesting question. Let's hold it off till the end. We did not solve that problem here, but these are some of the things that we need to solve as an industry, right? And we'll talk about that. And you can talk about why and how we can solve that. Basically, that's fundamental problems in the segment sizes that you have with HLS or any of the streaming protocols, and reducing that or moving to different protocols is one of the solutions. There are different other solutions. For example, multicast is another solution there where you can have almost synchronized delivery of packets to various users. Those are the kind of things that we have to think about as an industry. Okay, we haven't solved that yet.
Just a small question for
Sure.
clarification. So all this is happening in the client, not in the codec?
This is purely adaptive bit rates that is happening on the client. So the codec or the encoder is producing multiple bit rates. They are constant bit rates inside each bit rate, but there are multiple such bit rates being generated. Okay. Another key thing that we implemented for the NFL is we implemented recovery in the player. As you can imagine, the player or the device is going to the CDN to get the packets or the segments. And during the start of the game, you go and connect to a CDN, right? And in the process of the game, which is about 4 hours, you end up not necessarily being able to connect to the same CDN. There are CDN failures, there are problems in various places along the path that you may want to recover. And one of the things that we implemented is we implemented what we call as seamless recovery, where if a CDN fails, we are able to reconnect to a different CDN and recover without the user having any interaction. And you may ask, why are you not already supplying multiple CDNs to the player when it starts? That's because the game or the live event is long enough that even if you supply them with multiple CDNs, that information can change during the game. So we always make sure that if there is a failure, if there is a problem, the player still goes back to the system to figure out what CDN to connect to. So one of the things that happened during the game is that we had a failure. We had about 100,000 users that were connected to a CDN, and within a matter of about 20 seconds, we were able to fail them all over to a new CDN, even though that we had a problem. And this is kind of the improvements that we had to do. And you can see here that these are the kind of things that can help make the user experience transparent. Sure.
So basically, you have the first connection to the CDN, start something, and you're working with a single server, right?
Single CDN, not a single server.
Always you're playing with a single server at the time, at a particular time. So you're getting chunks from a single server. Then something happened, the player doesn't detect anything basically. Your algorithm detects something wrong, there is no response from the CDN, and you jump to another server. The player continues taking chunks as it is on the fly.
Yes.
This is how it happens.
Yes.
You always work with a single server.
No, not with a single server.
At a certain point of time.
No. So every chunk gets downloaded from the CDN. It's connecting to the CDN. So a TCP, potentially a new TCP connection is set up, potentially. If a connection, if the connection is not kept alive, which means that every segment, which is an 8-second segment or a 4-second segment, depending on how you configure your HLS protocol, you end up connecting to either the same server or a different server for every segment. And as you're downloading these segments, you can potentially have a CDN failure, which means that you're not able to reach that CDN at all, or the CDN itself does not have the segments.
How you synchronize the indexes?
I'm sorry, which indexes?
Indexes of HLS, how you synchronize those?
So the index,
One chunk from one server, how they get another chunk with a different index, or the same index, how you synchronize?
so the playlists are refetched when you connect the new CDN. So, but the playlist may be still the same.
Playlist is one,
Yeah.
but you refresh.
Yeah. Yeah. Go ahead.
How do you manage to
Latency for what?
between the live event and
Okay. Good question.
second question is, are you using your player on all devices? I mean, like also
Good question. So one, yes, on most devices we are using our own player. Certain devices like iOS, we do not use we use their player, the inbuilt iOS player. So we can't do recovery, or we potentially cannot do ABR in those devices.
So buffering rates were calculated in the iOS devices?
Yes, the buffering rates are still calculated because we are beaconing back that data. That is all in JavaScript. But for Roku and other devices, connected devices, most devices we built our own player and we distributed our own player. Second question, the latency. For this game, it was 24 seconds to 32 seconds because we had 8-second segments. 8-second segments means you have 3 segments in the buffer roughly, and therefore you have that delay. But we are thinking of reducing that in the future as well, so that we have much lower latency from the broadcast. Yeah.
It was from the broadcasting time for the same location or from the game or the game?
Come again, can you ask the same question? Sorry?
The question was if the delay that you counted, the 24 seconds was from the broadcasting
Yes.
in the same location.
Correct.
Location or in the game, in the court, in the game itself. Because the broadcasters have different.
Oh, the broadcasters usually have like a 5 or 8 second delay because they have to bleep out.
Much more.
No, I think they have about 5 seconds in the US. I don't know about here.
This is right for satellite, but for the wire, for cables, it's about 15 to 20.
So no, so we don't have the 15-second cable delay. We have the 8-second delay that they put for removing profanity and a bunch of things that they have to do because they want to bleep out profanity. So that's the delay that they introduce. From that point onwards is the delay that we introduce. Cool. I'll go to the next slide. So we talked about the innovations that we did from an adaptive bitrate perspective and also from a player recovery perspective. We also did a bunch of innovations where we were able to do the best routing for the user. And that's what I'll talk about delivery. So one of the things that you saw is that we distributed the experience on multiple destinations at Yahoo. We were able to show it on the phone, we were able to show it on TVs, we were able to show it on yahoo.com, on Tumblr, on desktops, on laptops, which means that we had to have different resolutions and different sizes for the player, for the screen. And now that makes it pretty challenging, right? So you have 5 different sizes. Now you have to have different bit rates or different resolutions that you encode the stream in. In addition to that, we wanted to, as I mentioned, we wanted to distribute it on different devices, right? Now, all of these devices have peculiar constraints. For example, if you go to Firefox as a browser, you are not going to be able to play 60 frames per second, right? If you go to a particular device like a Samsung TV or a different type of TV, you may not be able to play at a particular bitrate or a particular resolution. So these constraints were pretty complicated on devices as well. In addition to that, as I mentioned, various browsers were not supporting various capabilities. For example, like I mentioned, Firefox would not support 60 frames per second. And then we had to distribute this to different geographies as well. So across the world, we had to break down, I've put here geographies, but actually break down based on geos or ISPs. So we had to look at whether the user was on an ISP that could deliver a particular bitrate or not. Based on this, we had about 2,000 plus different combinations that the user could be at, and we had to make sure that the user received the best set of bit rates or profiles that they could watch. So what we did is we built the capability, what we call as the video routing policy API, which could then detect the user agent, could detect the device, could detect the operating system, detect the browser, detect which ISPs or which networks they are coming from, and then make sure they got the best set of profiles in their master playlists. So that's the kind of technology that we had to build. In addition to that, as the game was playing, there could be changes in the network, could be changes in the CDNs. Like I showed, one of the CDNs, right, almost about 30 minutes into the game, failed, which means that we had to decide that no users would be routed to that CDN. So during the game, we had to figure out that there is a problem in the CDN and reduce the routing of the users to that CDN to 0. Not only that, we also saw during the game that certain CDNs had much higher rebuffering ratios. So we had 7 CDNs, and we saw that one or two CDNs had much higher rebuffering. So we had to take users from that CDN or new users that would be allocated to that CDN and move them to a different set of CDNs. So you'll see here that at one point we saw some CDN problems. We decided that we'll reduce the users to that CDN. By the way, this graph shows time in the x-axis, and the y-axis is basically the number of concurrent users on that CDN. And then along towards the third part of the game, we saw that a certain CDN had much, much better performance than all other CDNs. Then we decided that rather than having users on lower performing CDNs, we move all our users to the best performing CDN, or as users were coming in, send them to the best performing CDN. So we were able to do many such optimizations during the game. In under 5 seconds, we could do this change. So anytime we noticed any issue or noticed that we were seeing performance problems or performance improvements, we could actually do that and make a change under 5 seconds, propagate that through all our API servers, and make sure that all our users, almost the 15 million users, were shifted around. Not only this, we did about 29 such changes during the game. So it was not just 3. So we were able to tweak and tune our network and our capabilities throughout the game to give the best performance to our users. And then I'll move to my final section where I talk about operations. So the game was being played in London. We were getting the feed through satellite and through fiber. The satellite feed reached 2 of our locations in the US. So you had failover capability. So if one site went down, we could always switch to another site. Yahoo has its own studios. We have studios in multiple locations. So we could get our feeds into our studios where we could do production and deliver from the video signal, packetize it and deliver it to our users. We have our backend systems. For example, we were collecting 100% beacons from the players. We were getting beacons every 30 seconds across the board, across all the users that were connected to our network. And we were not sampling it. We were getting 100% beacons because we were able to, we can scale to collect all the beacons and process them in real time. These were available in 5 of our data centers. In addition to the beacon servers, we also had backend API servers. The routing policy was also happening in the data centers. So 5 of our data centers around the world were doing all the API services. In addition to that, we had Yahoo has its own CDN, which we developed in Tel Aviv as well as in Sunnyvale. We have 30+ locations around the world. In addition to that, we had 6 other CDNs other than Yahoo's own CDN where we reserved capacity for this game. And in fact, we routed users to all the CDNs, as you saw. So you could actually measure and decide which CDNs to use in real time. So it was pretty massive scale operation that we did during the game. In addition to that, we have, like I mentioned, we have production studios in Yahoo. The production studios were one of the places where we were generating our own commentary during the game and then delivering it, stitching it together with the video signal and packetizing it and delivering it to our users. We have a control room also near our studios that we can use to monitor the systems, monitor the feed, monitor and work with NFL or CBS or whoever is supplying us with the video signal. In addition to that, we had a decision center where we had all our dashboards. We could see how our CDNs are doing. We could figure out what issues the users are facing and make executed decisions. Luckily for us, we were doing pretty well during the game. And this was because we practiced it quite a bit. In fact, before the game, we did 9 such events at scale, and we were able to test out our systems end-to-end. And in addition to testing out our systems end-to-end, we also did a bunch of chaos testing where we went and pulled plugs on various things to check whether all our systems were working as expected, and in fact, whether our operations center and our decision centers could actually react to it as well. So quite a bit of testing we did. So one of the advantages of being at Yahoo is that we have 1 billion users. So one of the things that we did is we ran a lot of our content to our users before the event. For example, we have music concerts, we have a fantasy football live that happens on every Sunday. So we could stream that to all our users and actually test our systems. So, cool. So I kind of walked everyone through the whole what we did for the NFL. What's next? So one of the things that we want to do is make Yahoo the premium destination for all live sporting events, not just live sports, but also live esports. We just announced that we are going to be one of the destinations for esports. I don't know if you guys have visited esports.yahoo.com. For those of you who don't know, esports is basically a new form of sporting events that happen for games, video games, or the console games. That's another thing that Yahoo has now launched. We actually live streamed a big event this last weekend, which was almost NFL scale, and we did that seamlessly. In fact, we did much better than the numbers that you see today here. It's one of the growing trends, and that's somewhere we want to be as well. So Yahoo is going to be the destination for a lot of the live sports events. We just started streaming PGA Golf Tour. We have also the contracts to live stream MLB Game of the Day starting in April. So we'll be starting to do that. In fact, you'll hear a lot of announcements about live sporting events that Yahoo is planning to do in the coming weeks as well. So that's one of the big things that we are going to do next.
All the services are free or free?
So that's a good question. So initially, what you see today is the question was: are all the live sporting events going to be free or are going to be premium?
Or geo-block to some territories? Or geo-block to some territories?
Oh, okay, that's another good question. So geo-block to some territories. So let me first answer the first question. We started off NFL as a free ad-supported model where anybody in the world could watch it. Our first initial set of sporting events are all going to be free. For example, MLB is going to be free, PGA is free. Now, about geo-blocking, it's going to be, it depends on the rights of the events, right? So some of the content is going to be purely in the US or in North America. Some of the content is going to be global. And depending on where depending on the content, it'll be whether it's free or global.
How do you deal with people who use VPN to bypass geo-blocking?
I don't think we can do anything.
Speak up.
Okay. So that was my presentation. I'll take questions now. Yes, to answer your question. Yes. So the syncing issue is clearly a big issue. So one of the things that we are working on is figuring out how to solve that problem. One of my favorite examples is I go to a sports bar. I have 3 TVs there. All the people in the sports bar are watching the game. Today, it's like, whatever, 200 milliseconds apart, maybe, right? With OTT streaming, it's going to be not synchronized. And it's going to be even a bad experience. Forget your neighbor. It's going to be a bad experience for sports bars and places where people go to watch the games. We are thinking of a bunch of ways in which we can solve that problem. It's not a solved problem, so it's something that we need to all work on as an industry. So multicast, some amount of geo-based synchronization are the things that we have to think about. Go ahead.
Please describe how you switch from CDNs for customers.
For existing viewers or for?
So a viewer was watching from one CDN and you identified a problem with that CDN.
Mm-hmm.
Technically, how did you do the rerouting to a different CDN for that user?
So the player has a mechanism of reaching the backend APIs. So it decides that it is watching on a particular CDN and it sees a problem. It's not able to get the segments. it contacts our backend APIs. Our backend API says these are the fallback CDNs, and it'll react to that.
That's a second control plane for the connection.
Of course, yeah. Go ahead. There are a bunch of questions here as well, but.
Do you know if it's a CDN problem or it's last mile problem?
That's a good question. We don't know that. If it's a last mile problem, there is no harm in trying a second CDN because anyway they're screwed. So you may as well try it. Go ahead.
I guess that you transcode your content into H.264.
Yes.
What about AGVC? Why not AGVC?
So because many of the devices that we work on will not have the decoder for HEVC, one of the reasons. And yes, it's also, we didn't want to try new things, especially for this event. We were tried and tested with H.264, and that's one of the reasons we didn't do that. We could have experimented for some devices with HEVC, which we did not. But we are going to try and do it. Yeah.
Can you switch CDN only on failure or also due to average low bit rate?
I couldn't hear the question, sorry.
You switch the CDN only on failure or also due to average low bit rate?
No. No. So that's again, there were a lot of open problems that we have not solved yet. For example, if there is too much of bitrate switching, should we actually change CDNs, right? So those are the kind of questions that we have not solved. Those are the things that we are thinking about. I mean, from a user experience perspective, is bitrate switching a good experience? Today, nobody measures that, right? Even if the average bitrate is constant, but we keep switching between two bitrates all the time, that's also not a good experience. So just because they have a high bitrate, average bitrate, does not mean that they are having a good experience. So those are the problems that we are thinking about. Yeah.
Do you use HLS on all platforms?
Yes. So that's a good question. Yeah. So we decided that HLS is the best way to go. In fact, we are going to go that way. Pretty much across the board, we are going with HLS across all platforms. Yes. So that's a good question. We did HTML5, pure HTML5 on Safari. We are working on pure HTML5 across all browsers. We have not announced that yet. So, but that's something that we are working on. Yes, today. Yeah. Go ahead.
You said that you were using 30 plus CDN locations.
30 plus POP locations.
So there was another layer of CDNs that was supporting you, or that was going directly to the end user?
So the 30 plus location were Yahoo CDN. So we have edge locations, 30 plus locations across the world. Obviously, the other CDNs have probably much higher locations as well. You can imagine there are a bunch of big CDNs in there. So yes, we had many, many locations around the world. The 30 plus was just the Yahoo locations.
Okay, so you were using Akamai or ChinaNet or whatever.
Yeah, I won't tell the names, but you can imagine the 6 biggest CDNs.
Who's that red line at the bottom? CDN, you have the graph?
I think that we are not going to talk about any of the CDNs in particular, but yeah, exactly.
In terms of decision to use HLS, why, it's interesting for me, why haven't you chosen Dash and you chose HLS?
So if we use Dash, we still have to choose HLS because we have players with HLS. We prefer to be, already we had a lot of complexity, as you can imagine. We didn't want to introduce more complexity by sending different users to different protocols and deal with that. In general, we want to keep it simple, and packetization we want to keep in a single protocol if possible. So that's one of the reasons.
But what do you think about Dash, in your opinion?
So I think Dash is definitely, we have been seriously considering that. It's definitely interesting from a
Basically, all the smart TVs today, they are looking at Dash.
yes.
Correct me if I'm wrong. Most of them. In terms of 4K, HEVC, and Dash. So
We are not, I think we should do Dash. We are not going to do it because we have that additional complexity today. At some point, we will also do Dash. It's not that we are not going to do Dash. It's just that it is too much complexity as it is, dealing with a lot of devices, dealing with a lot of CDNs. We didn't want to experiment with new protocols or packetization as well.
To solve multi-DRM issue, you need that.
Yes, yes, but that's a different topic. We didn't do DRM in this. So. We used Elemental, yeah. Right.
The player noticed a reduction in performance of one of the CDNs. Did it move to a different CDN, or did it try a different server within the same CDN? For instance, a long-haul server. So if the issue's in Germany,
Good question.
get it in the UK, for example.
Good question. So, no, we did not. We hope that the DNS resolution would do that. If the DNS resolution of the CDN does that, great. If you try a reconnect on the same CDN, before it fails back to the server and then tries a different CDN. That's a potential that we are trying within Yahoo CDN, because Yahoo CDN, we have much more control, right? So we can do a bunch of smart things like go to a long haul or do a bunch of things. No, in this, we did not do that.
Is 60 frames per second worth it?
Absolutely. Absolutely, without a question. I think we got a lot of feedback from users saying the quality was crystal clear, and we did a lot of user testing before we decided to do it, because that again added complexity. We had to increase the bit rate, do a bunch of things capacity-wise. But I think it was worth every penny, in my opinion. I think users loved it. And I could make out, at least I could make out the difference between 30 and 60, because, you know, motion.
But the question is if the user metrics also tell us in story.
It's difficult with user metrics, especially in internet streaming, where you have bitrate adaptation, because it's fluctuating so much that you don't know whether the user saw consistently the bitrate for a long enough time to recognize that it was 60 versus 30. In all the user testing that we did internally, we could clearly make out the difference between 30 and 60. I'm sure we can. I'm sure we can support, but we haven't thought about it yet for a lot of the sports. 60, at least I found it good enough. I'm sure. Yeah, we have not thought about it at least in the NFL context. So.
What's your published strategy? Basically, you have the elemental, correct?
Mm-hmm.
And you create a profile.
Mm-hmm.
And you have the package or inside elemental or external one. And how you publish to the origin? Do you use RTP, transfer streams, UDP? What do you use?
We directly connect to the CDNs, and we use, I believe they have TCP. I think Lev is the right person to talk about. I think different CDNs have different ways. Most of them we did pull, I guess, right?
Pull HLS?
Yes.
So you basically generate HLS?
Yes.
On the encoder itself?
Yes.
And you pull it from the caching basically to the CDN?
Yes.
This is what you do.
Yes. For some CDNs. For some CDNs we pushed.
You push what?
HLS.
HLS.
Yes. Yeah. That's a very interesting question, and I was just giving an example to somebody today. For the NFL, we did a lot of technology, a lot of preparation, we built a lot of capabilities, a lot of innovation. We did one event, right? And this last weekend, we had 7 events in parallel, different events. We had the esports, we had 3 or 4 esports events that happened in parallel. We did it almost at NFL scale. And we had many other events. And we did not have to do any preparation. And it was almost run the same way without any preparation because we had all the technology. So to answer your question, yes, most of the technology that we have built can support multiple events. Of course, one of our main goals was once we finished the NFL, my goal for the next quarter, which is almost coming up now, is I should be able to do 10 such events in a day, right? And that's where we are heading. Exactly.
In the same volume?
Yes.
Or
Of course. No. So
total the same volume and a bit higher.
it may be a bit higher.
Then
Yeah.
customer watch
Yeah.
one live.
Yeah. If we have 6 CDNs, we could do potentially, I'm just calculating quickly, roughly 3 to 4 of the same event possibly. Yeah, scale-wise. Yeah. Because we had reserved capacity for that much. And at least the CDNs told us that they can handle it. Yes, a lot of questions, sorry. Everything was on the CDNs. No, we did not use any peer-to-peer technology. Very good question. One of the things that we could do is use that Ravi, which is one of our acquisitions, actually had or has peer-to-peer technology. No, we have not done that yet.
The goal of the CDN, is that be a video CDN for other entities?
Yes, we are a video CDN for other entities if you have content, right? But if you're asking, we are going to sell it as a service? No. But we will be better than Akamai.
But only for your own property?
Yes, for our own content, right? So finally, our strategy is to take our audience, partner with the content providers, and host the events. We don't want to be a pure platform play because we have the audience and we can be partners. It's a different business model, yeah. Yeah. I can tell you for a fact, we have a lot of data. You looked at the graphs. Our CDN performs, in spite of having just 30 POPs, our CDN performs about 3 times better than them. We just did events last weekend. 3 to 4 times better than them. In rebuffering, in impacted users.
Well, must be in the US and other developing countries. The last mile is always going highly developed countries.
Not only the last mile, but the contrary, it's the mile before the last mile that is problematic.
And to answer the question in a different angle, we are not trying to compete with the CDNs. Finally, our goal is not just to compete with the CDNs. Our goal is to bring the audience, obviously give a much better experience than content providers going to some other CDN and monetize that well. So it's all 3 of it, not just become a platform play and just compete with the CDNs. Yeah. Mm-hmm.
The other is because you are content owners and you also a distributor, because of that you can create more interactive events with the viewers.
Yeah, so unfortunately I can't share the device. We have not publicly shared that information, so I can't share that. I believe we have shared the amount of minutes spent totally. I think we have done that, so you can do the math and figure out how much roughly each user watched the game for. It was pretty high. It was not like people just coming and getting it for like a couple of minutes and then going away. So It was in the, I believe it was in the 30 minutes or so. I forget the exact number. But you talked about interactive experiences. Obviously, we did not do that in the NFL. But you can imagine that given the fact that we have fantasy, Yahoo Fantasy, you have sports, we have people coming to Yahoo on a regular basis, they want to be able to interact with the video or with the content that we generate. For example, I was just giving the example today to somebody where you're watching a game, you're watching a player. I want to be able to click on that player and get all kinds of stats about that player, whether he's on my fantasy team, what other plays he has done, what is his career stats, so on and so forth, right? Given the fact that we have all that content and capabilities, we should be able to do that. And that's kind of the things that we want to bring to the sport viewing experience. In fact, in esports today, you can do a bunch of that as well.
When you plan to route on the traffic, because you're routing the player as well, you think of overlaying some kind of notification mechanism when there's an interesting event that's long form, game for non-Americans?
That again, I don't want to talk about our future roadmap, but yes, we are considering those kind of things. In fact, you will see a lot of this live sports highlights, which things like that will show up in our content. Yes.
Exploring the future to make a good player. Any plans for 360?
I mean, obviously, like everybody else, we are playing with that type of technology and content. But yeah, depends. I mean, one of the things that people have observed, in fact, I don't know if it was NBC or CBS, when they provided multiple angles. I mean, 360 is kind of some new experience, right? When they provide multiple angles to viewers, many of the viewers preferred the curated producer, editor generated content rather than watch it in a different angle. So while it's a fancy marketing tool, from a user experience and user engagement perspective, people prefer curated videos rather than 360 videos. So it's a toss-up. Once we get more information on whether users like the 360 is when we will try to engage with them on that.
Monetization, when you talk about advertising during the game and so on?
Yes. For this event, we decided very specifically that we will have a TV-like experience. So we did server-side video signal stitching of ads, and while we have done that, we have also started. In fact, we are not announced it yet, but we are also looking at mid-roll ad stitching across the board for live events. Cool. I think. Thanks a lot. Thank you very much.